Once upon a time, in a quiet laboratory, long before modern monitors and glowing screens, scientists searched for a medicine that could ease pain and bring comfort. What they found instead was something unexpected, a small molecule called sodium thiopental. It did not silence pain, but it carried a remarkable gift, the power to guide the brain gently into sleep. As this molecule slipped through the bloodstream and crossed into the brain, consciousness faded quietly, not through force, but through chemistry. And so, without knowing it, medicine took its first steps into the age of intravenous anesthesia, where sleep could be delivered not by masks or fear, but by understanding. As the story moved into the 1930s, the little molecule left the laboratory and entered the operating theater. In 1934, Dr. Ralph Waters, one of the quiet architects of modern anesthesia, noticed something remarkable. Patients fell asleep almost instantly, yet awoke again if left undisturbed. At the Mayo Clinic, Dr. John Lundy listened to this observation and gave it purpose, refining the technique and sharing it with the world. Surgery no longer had to begin with fear, masks, or long minutes of struggle. With a single injection, unconsciousness could arrive calmly, and anesthesia took a decisive step into the modern age. As the little molecule traveled through the bloodstream, its journey did not end in the heart or the lungs, but quietly continued toward the brain. Sodium thiopental slipped easily through the blood-brain barrier, drawn by its love for fat, and settled gently among the neurons. There, it strengthened the brain's own calming messenger, gamma-aminobutyric acid, allowing silence to spread from cell to cell. Thoughts slowed, awareness softened, and consciousness faded, not because the drug forced sleep, but because it encouraged the brain to rest. And just as quietly as it arrived, the thiopental soon left the brain again, drifting into muscle and fat, allowing the sleeper to wake, while the story continued elsewhere in the body. As the nights passed and experience grew, anesthetists began to trust this quiet companion. Sodium thiopental became the key that opened the door to surgery, allowing other medicines to follow and do their work. It was especially valued when the brain needed protection, slowing its activity, reducing its need for oxygen, and easing dangerous pressure within the skull. In operating theaters and intensive care units, it offered not just sleep, but control, a way to calm storms inside the head while time and skill guided recovery. And so thiopental earned its place, not as a cure, but as a guardian of fragile moments. With time and experience, doctors came to appreciate not only what thiopental could do, but also what it could not. It brought sleep swiftly, smoothly, and predictably, making it a trusted beginning to anesthesia for many years. Yet it offered no pain relief and demanded careful hands, for breathing could slow and blood pressure could fall if vigilance was lost. Used with respect, it served as a reliable guide into unconsciousness. Used without understanding, it revealed its dangers. And so, thiopental taught anesthetists an enduring lesson, that safety in medicine is never found in the drug alone, but in the knowledge of those who use it. But every good story has a warning whispered between the lines. Sodium thiopental could quiet the mind, yet it could also slow the breath and soften the heartbeat if not watched with care. Blood pressure might drift downward, breathing could fade into silence, and a misplaced injection could harm the tissues it touched. In certain bodies, especially those with hidden metabolic disorders, the drug could awaken danger instead of sleep. And so, thiopental reminded medicine that sleep is never given lightly. It must always be guarded by skill, knowledge, and constant attention. And as all stories grow older, change quietly follows. New medicines arrived, faster, clearer, and gentler in their recovery, and sodium thiopental slowly stepped back from the center of the stage. Drugs like propofol offered smoother awakenings and fewer lingering shadows, and so practice evolved. Yet thiopental was never forgotten, for it had shaped how anesthetists thought about sleep, safety, and the delicate balance between control and care. Its legacy lived on, not in routine use, but in the knowledge it helped build, A reminder that medicine moves forward by learning from every chapter, even those that close. Yet the story of sodium thiopental took a darker turn, far from operating theaters and healing hands. Because it could bring unconsciousness quickly, it was chosen as the first step in lethal injection protocols intended to ensure sleep before death. But questions soon followed about dosage, suffering, and whether sleep was always deep enough to protect against pain. As evidence and ethics collided, manufacturers refused to supply the drug for executions, and its use became a symbol of medicine pulled beyond its purpose. In time, sodium thiopental vanished from this role, leaving behind a lesson written not in pharmacology, but in conscience, that medicines created to heal lose their meaning when asked to do harm. But the story of sodium thiopental wandered even further from the operating theater into a realm where science and imagination became dangerously entangled. Because the drug softened anxiety and loosened speech, some believed it could uncover truth itself, and so it was given the name truth serum. Yet what thiopental truly dissolved was not deception, but resistance. Under its influence, minds became suggestible, eager to please, and vulnerable to ideas planted by others. Psychiatrists and courts eventually learned that memories could be shaped, stories guided, and false beliefs quietly inserted where certainty once lived. Science responded with evidence, ethics, and law, rejecting drug-induced testimony, exposing its unreliability, and drawing a firm boundary between healing the mind and invading it. And so, the myth of the truth serum faded, replaced by a harder truth that no chemical can manufacture honesty, and no medicine should ever be used to steal a person's thoughts. And so, as the night grows quiet, the story of sodium thiopental comes gently to rest. It was never a hero, nor a villain, but a powerful tool shaped by human hands and human choices. It taught medicine how to bring sleep without fear, how fragile the brain can be, and how easily science can be misunderstood when imagination runs ahead of evidence. From healing theaters to ethical boundaries, its journey reminds us that progress is not just about discovering new drugs, but about knowing when to stop, when to question, and when to protect what makes us human. And with that lesson safely learned, the lights dim, the mind settles, and the story, at last, is allowed to sleep.